Hi everyone, welcome to another video from SQL Maestros. And as I have been doing for the last few weeks, this tutorial is from our masterclass that I delivered a few weeks back. This masterclass is one of our most popular masterclasses titled as SQL Server Internals, Troubleshooting and Performance Tuning. It's a 40-hour program where we cover a lot of topics. We go very deep and we have a very wide coverage as well. Look at the screen and you can see all the 14 modules that we deliver, starting from the architecture, from weights, performance tuning, CPU, IO, memory, TempDB, query execution analysis, concurrency, query tuning, index tuning, extended events and whatnot. The breadth as well as the depth. So log on to sqlmaestros.com. You may access the recording of this masterclass or you may sign up for the next upcoming live class. Okay, let's get down to the demo, the tutorial for this video. Today we are going to talk about the ad hoc query caching. And again, it's a small snippet, a demo that I have picked up from this masterclass. Okay, let's click on the VM here and let's get down to the demo. So the file is already open in Management Studio. What am I going to demonstrate? So we are going to look at a tricky behavior of the plan cache, how ad hoc queries are cached and how their plans are created and stored inside the plan cache. The fundamentals is very straightforward. However, there is a tricky behavior that you need to be aware of, and that's the purpose of this video. Let's get started. We are going to use AdventureWorks 2016. I'm first freeing the proc cache. Remember that freeing the proc cache is not a typical thing that we do in production environment. I'm only doing it for the purpose of demo. Let's do this. Now there is a query here. Select star from person.person where last name is equal to Matthew. A simple select statement with a where clause, which means one parameter there. Let's go and execute this. You get the data out. Now let's jump into the execution plan cache. So we have this DMV dim exit cache plans, which will give us all the cached plans. And I also want the select statement. So I am cross applying this with the SQL text dynamic management function. Let's go and execute this and you will be able to see the execution plan that is stored in the plan cache for the query that we just ran. You can see a couple of metadata items out there. The cache object type is compiled plan and the object type is ad hoc because this was the ad hoc query. The DMF gives us the select statement and you can see an important attribute out there called use count, which is how many times this execution plan has been used. And we ran the query only once, so the use count is 1. Everything is very straightforward until this point. Now let's move forward. We're going to free the proc cache again. And now I am going to run this query 3 times. Okay, so let's go and do the first execution. There you go. We'll do the second execution, second time, all good. Let's do the third execution now. There you go, all good. Now let's go and look into the plan cache. You're not going to find any weird behavior here. Everything is all good. You have the text, you have the object type, the cache object type, and as expected, the use count is 3 because you ran the same select statement 3 times. Okay, let's move forward. Now what you will observe is something very tricky. I'm going to free the proc cache again and I'm going to run the same select statement 3 times again. Let's do the first execution, all good. Let's do the second execution, all good. And now the third time. There you go. Let's go and look into the plan cache and now you will find that there are 3 execution plans in the plan cache. You have the select statement here 3 times. You have the use count as 1 for each of them. Of course, because we executed the query 3 times and for whatever reason, SQL Server decided to create 3 different execution plans, 1 for each execution of the select statement. Now, while I was executing the query, you have probably already figured out what was going on. But if not, I'll give you a few seconds. Okay, so what I'm going to do is just scroll up and expand this here as well. Take a closer look. Let's take a closer look. Let's zoom out a bit. Yeah, take a closer look at the select statements and the text that we get from the DMV. Do you find something inconsistent here. Okay, you're watching, you're reading through, and by now you have already figured out that the parameter looks a little different. So we have Matthew here with capital M, you have Matthew here with all small letters, and you have Matthew here which is all caps. And this is what you can see even internally from SQL Server. Which means even though all the three select statements are same, they are not textually identical. Yes, for ad hoc queries, for ad hoc query caching, SQL Server would love to have the same query coming back again, but it has to be or should be textually identical for SQL Server to reuse an existing execution plan. So if I just zoom out and scroll up, in the previous execution, when the three select statements just produced one execution plan, if you look at Matthew, Matthew, and Matthew, they are the same, textually identical. And purposely for the next execution, I just changed a few characters here and there. So friends, this is not about case sensitivity. It is about textual identicalness of the query. So the query character by character needs to be textually identical. Even something like last name here, if I just put L here, small l, it makes it different than the next query. So this is what you need to be aware of, that inside SQL Server plan cache behavior for ad hoc queries, it's always advisable that the queries, the ad hoc queries, the incoming ones are textually identical. Now this is a problem. This is really a problem because let's assume you have hundreds of such select statements coming from the client and each of them have a different parameter value. Let's say you have Matthew, you have Miller, you have Bill, you have Bunsell, you have something else. So each ad hoc query is actually going to create a different execution plan if we just focus on the ad hoc query caching. And this may lead to what we call as the plan cache bloating. Plan cache bloating is this scenario where you have so many ad hoc execution plans in the plan cache and their use count is just once, which means they were used only once and now they're just lying in the plan cache without a purpose. Okay, so now you know the tricky behavior, you know how things work with ad hoc queries, you know what the problem is, and now you're figuring out or wondering what the solution could be. Well, there are a couple of solutions that we can talk about, and specifically parameterization. The world of parameterization in SQL Server is huge. It's a larger discussion, but what I've done is I've recorded another video where I've shown you a quick solution. That video is available in our premium section of the YouTube channel. So if you go to the members only section, you will be able to see the video out there, or you can go to sqlmaestros.com and explore the premium membership where I talk about the solution and I've done the same demo with the solution, and hopefully you will learn something new out there. So I hope the video was useful where you have learned what the problem is, and I'm sure you're going to be able to figure out the solution yourself or just watch the videos in our premium channel or premium membership on SQL Maestros. Hope you enjoyed the video. See you soon in another video. Happy SQL! If you like the content, give it a thumbs up, subscribe to the channel and click on the bell icon so that you're notified on new videos. Most importantly, visit sqlmaestros.com. There's a lot of SQL learning resources out there, video courses, master classes, lab kits, ebooks, blogs, hands-on labs, and a lot more. Follow us on Twitter @SQLMaestros and myself _Bunsell. Last but not the least, do subscribe to our newsletters. See you soon in another video. Goodbye.